Hey everyone, and welcome. Today we're going to tackle something that might sound a little intimidating, statistics. But trust me, it's not what you think. We're going to show you how just a handful of simple tools can help you make sense of all the data that's shaping your world. From your weekly grocery bill all the way to big financial decisions. So let's jump right in.
Think about it. We're just drowning in information every single day, right? So how do you actually cut through all that noise? How do you find the real story that's hiding in a sea of numbers? Well, that right there is what statistics is all about. It's basically a toolkit for turning total chaos into crystal clear understanding.
And the best way to get your head around this is to picture a toolkit. Seriously, just like a carpenter has a hammer and a saw, anyone trying to understand data has a set of tools to build understanding. So today, we're going to pop open that toolkit and take a peek inside at the absolute essentials, the stuff you'll use again and again. All right, first up, the first set of tools in our kit has one really simple job: finding the center. The heart of our data, where's the middle? What's the most typical representative value? Let's dig in. So let's imagine all your data is like a town. Now, if I asked you to find the center of that town, what would you do? Because, there's not just one answer. You could be talking about the exact mathematical center, or maybe the geographical middle, or hey, maybe it's just the most popular spot where everyone hangs out. Each of our first three tools is like a different kind of signpost, and each one points to the middle in its own special way. Okay, let's kick things off with the big one, the most famous tool in the box, the mean. You almost definitely know this as the average. It is the absolute workhorse of statistics. And the way you find it? Super simple. You just add up all your numbers and then divide by how many numbers you have. That's it. Simple, powerful, and you see it everywhere. And you probably use the mean all the time without even realizing it. Ever figured out your average test score? Or your average commute time to work? Or, what about your average weekly grocery bill? That's the mean. It just gives you one single, handy number that sums up what's typical. So let's see this thing in action. Take a look at this table. It's super simple. We've got 4 weeks of grocery spending. 50 quid, then 60, then 40, then 70. Okay, add them all up. That gets you to 220. Now divide that by the 4 weeks, and boom, your mean weekly spend is 55 pounds. See that? One single number just summed up your whole month of shopping. All right, tool number 2 is the median. Now, if the mean is the kind of mathematical center, think of the median as the geographical center. It's actually even easier to find. You just line up all your numbers in order, from smallest to biggest, and you pick the one that's sitting smack dab in the middle. But hold on, you might be thinking, why do we need another way to find the middle? And this is where the median is absolutely brilliant. It doesn't get fooled by extreme numbers, what we call outliers. So picture a street with a bunch of regular, everyday houses and one giant crazy mansion at the end. The mean house price would get yanked way up by that mansion, right? It would give you a totally misleading idea of what houses on that street cost. The median, though, it just finds the house in the middle of the list. It completely ignores the giant mansion and gives you a way, way better idea of a typical price. So this is the key takeaway here. It's all about choosing the right tool for the job. If your data is pretty balanced and even, the mean is awesome. But the moment you have a few really extreme values, that giant mansion or maybe a CEO's salary and a list of company wages, those numbers can seriously skew the mean. They just drag it in their direction. The median doesn't care. It's not bothered by those extremes, so it often gives you a more honest, more reliable picture of the real center. Okay, our third and final tool for finding the center is the mode. And this one is the easiest of them all for sure. It's just the number that shows up the most often. That's it. The most popular, the most frequent choice in your entire set of data. And you might wonder, why is that useful? Well, think about a shoe store. The manager doesn't really care about the average shoe size, do they? What they really care about is the single most common shoe size. Why? Because that's the one they need to stock the most of. That's the mode in action. It's all about finding what's most popular, and that can be seriously valuable info. Okay, deep breath. We've figured out how to find the center of our data. Awesome. But that's really only half the story. Knowing the center is great, but now we need to know how spread out everything is. Is all our data clustered together like a dense city center, or is it spread all over the place like a sprawling suburb? In the stats world, we call this the spread or dispersion. So let's grab the tools for measuring that. And I absolutely love this next analogy. Think of it this way. If finding the center
the mean or the median is like aiming for the bullseye on a dartboard, then measuring the spread tells you how good your aim actually was, right? Are all your darts packed tightly right around that bullseye, or are they kind of scattered all over the board?
The simplest tool for this is called the range. It's dead simple. You just find the highest number and subtract the lowest number. So if the temperature this week went from a low of 10 degrees to a high of 28, the range is 18 degrees. Done. It gives you a super quick snapshot of the total spread.
But, just like our friend the mean, the range can also get totally fooled by outliers. You know, one crazy heat wave or a sudden cold snap could make the weekly range look enormous. And that's where a smarter tool comes in, the interquartile range, or IQR for short. It's way more robust because it ignores the extremes and just focuses on the spread of the middle 50% of your data.
So, how does it do that? It's actually pretty cool. Imagine you've got a list of all the salaries in a company. To find the IQR, you first line them all up. Then you literally chop off the lowest 25%, so goodbye to the intern and entry-level salaries. Then you chop off the highest 25%. See you later, CEO and top executives. The range of whatever's left in the middle, that's your IQR. It tells you the salary spread for the main bulk of the employees, completely ignoring those crazy extremes at either end.
And finally, we get to the big one, the most powerful tool for measuring spread, standard deviation. Now, the math behind it is a bit more involved, but the core idea is actually pretty simple. It basically figures out the average distance of every single data point from the mean. So a small standard deviation means everything is clustered really tightly around that average. A large one? It means your data is spread all over the place.
And this is where you see its real-world power. In the world of investing, a stock with a high standard deviation means its price is jumping all over the place. It's super volatile, it's risky. Or think about a marathon runner. A high standard deviation in their race times means they're totally inconsistent. Sometimes they're fast, sometimes they're slow. You never know what you're going to get. Standard deviation is basically a measure of consistency, of reliability. Okay, so now we've got our two sets of tools, right? One for finding the center and another for measuring the spread. But here's the thing. The real magic, the real insight, happens when you put them together. That's how you finally see the whole picture.
Just look at this example. We've got two runners, runner A and runner B. Now, at first glance, they look exactly the same. They both have a mean and average finishing time of 3 hours and 30 minutes. Identical, right? But now look at the standard deviation. Runner A has a tiny 2-minute deviation. That means they are rock-solid consistent. They finish around 3:30 every single time. Runner B, though, they have a massive 20-minute standard deviation. They are completely unpredictable.
So let me ask you, who would you put your money on in the next race? See? The average time by itself is totally useless information here. It's the combination of the center, that mean time, and the spread, the standard deviation, that tells you the real story. You absolutely have to have both to know what's going on.
So let's wrap this up. Your tools for central tendency, the mean, the median, they show you the target, the bullseye. Your tools for dispersion, like standard deviation, they tell you how consistent you are, how tightly clustered your shots are around that bullseye. And the most important thing to remember is you always need both to get the full story. So from now on, the next time you see a headline about an average price, or you check the average temperature, or see an average rating for a movie, I want you to stop and ask yourself, okay, but what's the spread? What's the rest of the story? Now that you've got these tools in your own toolkit, what numbers are you going to start looking at a little differently?